Hello my dear students, this is Akash SD and welcome to the NEET JEE Physics classes. Hope so you all are doing really great. So students, in this video we are going to learn the topic redistribution of charges and loss of energy. Here we are going to learn when two charge conductors are connected by the conducting wire, then what will happen? The charge will flow from one conductor to another conductor. Why the charge will flow? The charge will flow because of the potential difference. Okay, and when this charge flow will stop? This charge flow will stop when the potential of both the conductors will become equal. Okay, so all these basics we are going to learn in this video. Let's start the video and let's learn all the basic things related to all this. Okay, so here you can see when two charge conductors are connected by a conducting wire, now then charge flows from a conductor at higher potential to that at a lower potential. Now, as I have told you, now see, this flow of charge stops when the potential of two conductors become equal, as we have discussed. Now after that, see, now we are going to analyze the situation. So see here, let the amount of charges before the conductors are connected are Q1 and Q2 respectively, while the potential is V1 and V2 respectively. So you can see here very well students, here two conductors are there, initial charges on them how much here? Q1 and Q2, and potential of them how much here? V1 and V2, initial situation. After that what is going to happen? They are going to connected by the wire. Okay, so let's see here. Now see, similarly the amount of charges after the conductors are connected are Q1 and Q2 dash respectively, while the potential of each how much here? V. So here we have taken the two situations. Now this is the initial situation, this is the final situation. So see here students, here let's take the initial charge on the conductor, how much is there? Q1. Now like this you can keep it here, is it? And Q1, its potential how much here? V1, okay, and its capacitance how much is there? C1, okay. Similarly, let's take here another conductor is there, is it? This another conductor. Now anyhow you can see the radius is R2 and how much charge is there? Let's take the charge is Q2, potential is the V2 and the capacitance is C2, okay. Now students, after that what will happen that here, even if I write here the total charge, now total charge, this is a which situation? Initial situation, initial. So here if I write here the total charge, now because later I have to use this, but I am writing here, see the total charge on this system how much here? Q equal to Q1 plus Q2. Now please remember that here, this one. Now after that what will happen that students, here these conductors will be connected by one wire. Which wire? Conducting wire. Okay, so when they will be connected by the conducting wire, what will happen? The charge flow will stop from the higher potential to the lower potential. Okay, so let's take for example, when this flow will stop, means this flow will start, then what will happen that students? When the potential of both the conductors will become equal. So that time what is there? Let's take here the charge how much here? Q1 dash. Now as we have seen, capacitance does not depends upon the charge, so same C1 only. And after that potential how much? A common potential V. Okay. Similarly here students, see here again let's take the charge. Now, how much charge is there? Let's take here the charge is the Q2 dash, capacitance anyhow C2, and the common potential how much here? V. Okay. And here if I write here students, here this is the which situation? Final situation. Final situation. Now and here remember that one thing, here we will use here one capacitance formula of the sphere. What is the formula of the capacitance? We can write here C equal to 4 pi epsilon naught R, and here you can see here this C is the directly proportional to R. Okay, so wherever ratios will come at the place of capacitance, we can write the radius also. Okay, so you can see very well the initial situation and the final situation. Okay, great. So now we are going to see some important terms like what is the common potential, and after that we will see what are the charges will come when they are connected by the wires. Now all these things we are going to see. So now see here students. So here what we are going to see? We are going to see the common potential. Common potential means here we are going to use here the conservation of charge. Okay, because for the this one isolated system, so we can write here, see, from conservation of charge. Now let me write here, from conservation of charge. From conservation of charge. So what will be there? Initial charge, that means before connection, will be equal to final charge. Final charge. Okay. So students, we can see here initial charge was how much here, as I have told you, Q also, and it was how much here, Q1 plus Q2. Is it? Final charge how much on both of the conductors? We can write here, see, Q1 dash plus Q2 dash. Is it? And for the capacitance, you know the formula, no? Charge stored in a capacitor is always given by Q equal to CV. Is it? So here, students, let me just write here. No? First, let me write here like this. See, Q1 plus Q2. First, I will write in this form. Q1 dash means I can write here, see, C1 into V. No? And Q2 dash, what this will come here? It will come here, C2 into V. No? Remember that. So from here, if I write here the common potential, this V will become what here? We can write here, see, Q1 plus Q2 by C1 plus C2. No? This is the one thing. We can write here what is the common potential. Can you see very well? V equal to Q1 plus Q2 by C1 plus C2. After that, you know very well, this Q1 we can write C1 V1, Q2 we can write C2 V2. See here, even I can write here, see. If here I want to write here the Q1, so what this will happen that here? I can tell also, see here. Here, students, I can write here, this Q1 is the what is C1 V1. Now, remember that here. This Q2 how much here? C2 V2. Similarly here, this Q1 dash. Q1 dash how much is there? C1 V. And here, students, see this Q2 dash how much is there? C2 V. Okay. So this thing we will use it time to time. Now, so see. So here what will happen that here, this Q1, Q2, I am going to put the value. So we can get one more formula. This common potential is also given by this one. See, C1 V1 plus C2 V2 by C1 plus C2. Now, this is the formula is there. Now, C1 V1 plus C2 V2 by C1 plus C2. If we write in terms of the radius, then one more formula we can get here. Remember that here, V1. Now, this common potential. C1 what we can write here, see, 4 pi epsilon naught R1 into V1 plus here 4 pi epsilon naught R2 into V2. And here what will happen that here, 4 pi epsilon naught R1 plus 4 pi epsilon naught R2. Is it? So 4 pi epsilon naught in the numerator and denominator will cancel out. Okay. So here, if I write here the potential formula, so what this will become here, we can write here, see, we can write, see, R1 V1 plus R2 V2 by what this will come here, R1 plus R2. Okay. So this is also one of the formula of the common potential. So students, here you can see this formula we have got common potential in terms of the charge and the capacitance. Here we have got in terms of capacitance and the voltage, and here again we have got in terms of the voltage and the radius. Is it? So any formula can be used depending upon the situation. Okay, great. Now students, after that, next one we are going to see what is, see, very important, see, charges after connection. So when both the conductors are connected by the wire, what was the charges was there? Q1 dash and Q2 dash. Is it? So let me write one by one. If I write here the first one, Q1 dash. Q1 dash, what was the value? C1 into V. Correct? No? C1 into V. So here what we can write here, see, this is C1 and the V value, if I write in terms of charge, see here, Q1 plus Q2 by C1 plus C2. Is it? So we can write this formula. Is it? If in case you want to write in a another form also, no? So you can write in another form also, but see, I will write here like this. This formula is a very important. See, C1 by C1 plus C2 and Q1 plus Q2. Q1 plus Q2, students, what I have told you, see, this Q1 plus Q2, total charge, what I have told you, Q. Is it? So this formula is the very important. That's why I'm writing here, C. Now, so what will coming here? C1 by C1 plus C2 into Q, total charge. Okay. Similarly, after that, if I write here the charge on the second conductor, so what this will come here? C2 into V. Is it? So again, you see here the C2, and let me write here the values. So see here, Q1 plus Q2 by C1 plus C2. So what this will become here? It will become here the C2 by C1 plus C2 into Q. Here I am just writing in one form. Depending upon the question, you can use other forms and all also. No problem. After that, remember, write here one more thing. Sometimes it is useful. If in case I write here the ratio Q1 dash by Q2 dash, what this will become here? This will become here, see, C1V by C2V. Now see, C1V by C2V. So this will cancel out, V and V cancel, so we can write here Q1 dash by Q2 dash is equal to C1 by C2. Okay, so this thing also you have to remember that we have calculated the charge after the connection. Okay, now after that one important case is there, even we used to learn in the electrostatics also. See, a special case. So what is the special case? See here, if both the conductors are identical in which, in the shape. So what we can write here, see, R1 equal to R2 equal to R. Then you know what will happen that if I write here the charges, see this Q1 dash. Identical conductor means what will happen that here R1 equal to R2 equal to R. That means from here I can tell the capacitance also C1 equal to C2 equal to C. Now this capacitance will be there because capacitance depends upon the radius. If the radius is the same, then capacitance will be also same. So see here, if I see here, see this Q1 dash, what this will become here, see, I can write here C into Q1 plus Q2 by how much is coming here, C plus C. Now, so C plus C means 2C, 1C cancel. That means what we can write here, for identical shape conductor only this formula will be valid here. Now Q1 dash equal to how much coming, Q1 plus Q2 by 2, even you can write Q by 2 also, no problem. Okay, similarly after that if I write here the Q2, now Q2 dash, what this will come here again, see C, and here how much here, Q1 plus Q2 by C plus C. This formula I am using here, this one here. Okay, that means again what this will become here, Q2 dash equal to Q1 plus Q2 by 2. So students, again I am telling this formula is applicable when the conductors are having the same radius, or we can tell they are the identical. Otherwise, if they are not identical, radius is different, then we have to use this formula. If they are identical, radius is same, then only we can use directly this formula. Is it? I hope so. This is very clear. Great. So now students, after that, let's say the loss of energy. Third one, loss of energy, because what will happen that the moment the conductors will be connected by the wire, then charges will flow. So when the charge will flow through the wire, because of the Joule's law of heating, the wire will get heated, and in this process what will happen, some energy will be lost as a heat. Now that we are going to see. So see here students, see, when charge flows through the conducting wire, now then energy is lost as a heat, as I have told you, on account of Joule's heating effect. On account of what? Joule's heating effect. So here if I write here, see, if I write here this change in energy, delta U equal to U after connection. What I am writing here, the after connection. Now when both the conductors are connected by the wire, minus U before connection. Now BC means before connection. So what will happen that here, if I write here the after connection, so after connection, you know very well, capacitance is anyhow C1, C2 only, but the potential is what? Common potential, V. That means after connection, we can write here, see, half C1 V square plus half C2 V square. This is the total energy after connection. Okay, minus, minus. Before connection, you know the situation very well, the capacitance is C1 and the voltage was V1 for the first conductor, so this is the energy, plus half C2 V2 square. Okay, so students, after that what will happen when you will simplify this? So this delta U will come here, again I am writing a C, minus half C1 C2 by C1 plus C2, very handy formula, please remember that here, and here how much will come here? V1 minus V2 whole square. Okay, this formula you have to remember that here. Okay, because you know very well V is given by C1 V1 plus C2 V2 by C1 plus C2. So by using all these formulas and all, we will just get this here. Okay, and after that remember that one more thing, students, see, this delta U is the change in energy. Okay, V1 minus V2 square is always positive, and this capacitance is also positive. So you know very well, we can tell here, see, this delta U is coming what? This delta U is coming negative. So students, when delta U is coming negative, that means what we can tell here, students, from here. If it is coming negative means we can tell here, students, now this U after connection is less than U before connection. So from here what we can get here, we can get it anyhow some energy is lost. That's why after connection energy is less than the before connection energy. And how this energy has lost? This energy has lost as a heat. Is it? Remember that? I hope so. This is very clear. Is it? Great. Now students, let's see here one question. Now because whatever we have learned now, let's apply all this. So see, important for the NEET and JEE, the question is, see, two metallic spheres of radii 1 centimeter and 3 centimeter are given charges 10 microcoulomb and 6 microcoulomb respectively. If they are connected by conducting wire, then final charge on smaller and larger sphere is how much respectively. Okay, so what we are going to do first we are going to find out the, means we are going to give the some names and all. So let's take here this 1 centimeter is the R1, 3 centimeter is what, R2, and after that let's take this 10 microcoulomb is the Q1, and this is 6 microcoulomb is what, Q2. Okay, and we are going to find the charges. So smaller one means 1 centimeter is the smaller, so here I will give here this Q1 dash. Okay, and this larger one I will give here Q2 dash. Now so all these things are ready. So after that we know that very well, see, we know that see here this Q1 dash is given by, let's go to the formula anyhow. Now formula is there now, see this Q1 dash, what was coming students, see here please. See this C1 by C1 plus C2 into Q, but you know capacitance is directly proportional to radius. So this C1 by C1 plus C2 I can write even R1 by R1 plus R2. Why is it? So see it please. Now so this Q1 dash again I am writing here, see C1 by C1 plus C2 into Q1 plus Q2. Is it? And as I have told you very well, this C is the directly proportional to the radius. So what we can write here, see this R1 by R1 plus R2 into this charge Q1 plus Q2. Is it? So anyhow students, let me put here the values and all that here. R1 how much is there? See R1 1. So 1 by 1 plus 3, na? 1 by 1 plus 3, centimeter will cancel out. Q1 plus Q2 how much is there? Q1 is the 10, Q2 is 6. So 10 plus 6 how much it will come here? The 16. Anyhow unit microcoulomb is there. Okay. So what this will come here? 1 by 4 into 16. So what this will come here? It will come here students 4 microcoulomb. Now the charge on the smaller one how much coming here? 4 microcoulomb. Okay. After that if I write here the charge on the second one, no? Q2 dash. Q2 dash what this will come here? See this R2 by R1 plus R2 now into Q1 plus Q2. Now this is the formula. Q1 plus Q2. Okay. So R2 how much is there? 3 by 1 plus 3 into how much coming? 16 microcoulomb. So how much it will become here? See 3 by 4 into 16. So when you will solve here, it will come here the 12 microcoulomb. Is it? Even students in another way you can do like this also, like Q2 dash plus Q1 dash is equal to Q1 plus Q2. Now this is also you can use it, no problem. So what this will come here? Q2 dash means Q1 plus Q2 how much? Q1 plus Q2 16 minus this Q1 dash how much we have got already before we have got here the 4. Is it? So anyhow what this will come here? It will come here the 12 microcoulomb. Is it? So anyhow you can calculate, that's not a problem. So how much coming here? On the smaller one 4 and on the larger one 12. That means correct answer is here option A is the answer. Why the charges are coming different? Because the shape not shape, what we can tell, the size of the conductor is not same, the radius is different. Is it? Now after that students here again see, again because this is very important, that's why I am doing here. See a special case here for identical shape metallic spheres. When the spheres are in identical shape, then only what will happen that here, if I write here the Q1 dash will come what here, then only this formula is the useful, Q1 plus Q2 by 2. So anyhow Q1 plus Q2 total it was how much is 16, is it? So we can write here the 16 by 2, how much coming here? 8 microcoulomb. And similarly if we do here Q2 dash also in the same way, Q2 dash also in the same way for the identical one, then again what will come here? 16 by 2, and what this will come here? 8 microcoulomb. So you have seen very well, when the conductors are not same radius, then the charges are different. Here you have seen 4 and 12. But when they are having the same shape, same means same radius, then what is there? The charge on each of them is what is same. And which formula we have used? We have used the formula Q1 plus Q2 by 2. Is it? See how much easy way we are going through it. Now students, these kinds of questions are important for the exam, the CBSE, JEE, NEET, anything. So see here, a capacitor of capacity C1 is charged up to V volt, and then connected to an uncharged capacitor of capacity C2, na, as shown in circuit diagram. Na, first charged, then after that discharged to C2. So what they are asking, calculate common potential difference. Common potential difference across each capacitance, and after that we have to calculate percentage energy loss also. Okay. So what is happening that first we are going to charge na. So what will happen that here first this S will be connected to 1. Na. So first what is there? First this S is going to connect with the 1. So when S will connect with the 1, what will happen? This capacitor will charge, is it? So when this capacitor will charge, what will happen that here? It will store some charge and it will store some energy also. Okay. So see here, this initial charge is given by capacitance is C1 and the potential is how much here? V. So C1 V. Okay. After that, if I ask about here the energy, so how much energy it will store? U1 if I write here, it will come here what, students? See, half C1 into V square. Is it? When S came in contact with 1. Okay. After that, what will happen that here? Students, see second one. Now, when S will come in contact with 2. Okay. Now this, it will go in contact with 2. So when it will go in contact with 2, what will happen that here? This kind of situation will form here. Okay. See like this. This kind of situation will form here. Now, because here S and 2 is came in contact. So here what is there? Anyhow capacitance C1, here C2. And what is happening that here, students? Here before itself a charge is there. So what will happen? Redistribution of charge will take place. So what we can tell here, students, here the initial charge, that means this Q1, this initial charge Q1, na, this initial charge was there, na, that is going to distribute between these capacitors. Till what time? Till the potential of both of them will become equal. Okay. Till that only the charge transfer will take place, is it? So what we can tell here, this Q1 is equal to what? We can write here, see, Q1 dash and plus Q2 dash. Now let's take here after the flow of the charge and all that. Here how much here? Q1 dash is there. Here how much is there? Q2 dash is there. Okay, so what we can write here, see, this we can write here, see, C1V. Q1 dash how much is there? See, C1V dash. Na? Here potential how much? V dash plus C2V dash. Is it? So after that, when you will write here the value of V dash, let me write here the value of V dash here. So V dash will come here, see, it will become here, see, C1 by C1 plus C2 into V. Is it? So just let me write here, see, this is the formula is there. Common potential formula. Depending upon if they are putting dielectric and all that, sometimes maybe C1 is C, C2 is the Kc, formula will come V by 1 plus K. Na, then depending upon the question, you can analyze it, not problem, but this you remember that here. Okay, so this one we have got here the common potential. After that, what is there? Percentage energy loss. So initial energy, how much is there? Half C1V square. But final energy what will come here? If I write here the energy, so here also some energy, here also some energy. Okay. So students, if we go for the final energy, if we talk about the energy, so we can write here this U2, final energy, U2. Because final energy, let me write here the, not U2, let me write here the UF actually. Okay, no problem. Okay, so see the students here, if I write here the energy here, U final energy, what this will happen that here, first capacitor will store the energy, what this will come here, half C1 V dash square plus half C2 V dash square. Now this is the final energy stored in both the capacitors. Okay. So after that, what this will become here, I can write here, see, half C1 plus C2 into V dash square. Okay. So students, this final energy is given here what? Half, and we can write here, see, C1 plus C2 and V dash value, what we have got here, see, this V dash value, C1 by C1 plus C2 into V. Is it? So here we can write, see, C1 by C1 plus C2 whole square into V square. Now because square is there. So anyhow, if I write here, this final energy will come what here? Half, and C1 plus C2 here, C1 plus C2 here. So see here, C1 square by C1 plus C2 into V square. Okay. And remember that one more thing here. This is the initial energy was there. Na, see, let's take, I'm taking here, this is the initial energy, na, because when it has charged. So energy loss is there, energy loss. Now, so students here please, if I go for the energy loss, so first I am going to see fractional energy loss. Very, very important formula. That's why we are doing all this. Fractional energy loss. Fractional energy loss, students, is given by here, see, UF minus UI by UI. Is it? So what we can write here? This one will become here UF by UI minus 1. Is it? So after that, students, if I write here this UF by UI. So UF, how much is there? This one. Let me write here, see, half, which is coming here C1 square by what is coming? C1 plus C2 into V square by initial how much is there? Half C1 V square, and anyhow this minus 1 is there. Okay. So students, we have to just simplify this now. Just we have to keep some patience. This half and half cancel. Okay. And what will be there? From this 1 C1, this 1 C1 cancel, V square cancel. So students, what this will come here? It will come here, see, C1 by C1 plus C2 minus 1. Okay. So if we will take the LCM is there, see the LCM is C1 plus C2. So here C1 minus here C1 plus C2. Okay. So students, when you will simplify this will come what? Minus C2 by C1 plus C2. Minus C2 by C1 plus C2, that means here also the some energy has lost as a heat. And if in case they ask here the percentage, just multiply this expression with the hand rate, you will just get the answer. Is it, students? So I hope so this is the very clear. Is it? Now we are going to move for the this one. This question also coming regularly, and let's see here now little bit different question, but let's see. See, two identical capacitors C1 and C2. Now according to the question identical they have given, but C1 and C2 can have any values. Here they have given each of 2 microfarad capacitances are connected to 5 volt battery as shown in circuit diagram. Now you can see here, students. Now after that, see, when switch S is open and dielectric slabs K equal to 5 are filled in both capacitors, how will the charge, potential and potential energy be affected in capacitors after the slabs are inserted? Okay. So we have to analyze one by one. Now how we are going to analyze here? Let's see here. First, see here, they are telling that here when the switch S is open. So first what is there? This switch is closed. Now what is there when the switch is closed? So first analyze the situation when S is closed. Okay. S is closed. So when S is closed, what will happen? We are going to see one by one. Okay. So see here. If I write here in this capacitance C1, how much charge it will store? It will come here. Q1 is the C1V. Is it? This one is there anyhow. And after that, if I ask about here the energy, how much energy it will store? Half C1 V square. Is it? Similarly, after that, if we talk about this capacitor is also connected in a parallel with the battery. So here also this Q2 will be how much is there? We can write here see C2V. And this energy what we can write here U2 equal to half C2 V square. This is the initial situation. Okay. After that, what has happened, students? This switch has opened. What has happened? This switch has opened. So when the switch will open, then you can see very well this capacitor C1 is already connected. Nah? And after opening the switch, here we put one dielectric K, and here also we put one dielectric K is there. Okay. So in this situation, what will happen that here this new capacitance C1 dash will become here KC1. Now that we know very well, na, complete dielectric. And what will happen? This C2 dash will become water. This will become here the KC2. Is it? Because C equal to KC naught. Is it? So now we are going to analyze one by one C1 and C2. Okay. So C1 means you see the C1 is anyhow is connected to the battery. So when the C1 is connected to the battery, the potential difference across the capacitor is going to be constant. Okay. So now what we are going to do? We are going to calculate here the new charge and energy across the this one here. Across the 1 meter, this one here, see, across this capacitor here, C1, not charge and energy here. Okay, so see here please. Second one, when switch is open, so see here, S is open. Now students, see, S is open. So students, first one we are going to see for the this not Q1 actually C1, no, C1. Okay, this C1 here. So students, if I ask about here the charge, so new charge. Q1 dash will become what here? See, it will become here the C1 dash into V. Anyhow, the potential is same only. And C1 dash, what I have told you, KC1 into V. Is it? And what is the, what we can tell C1V? The C1V was a Q1. So what will happen that here? This new charge Q1 dash will come here water. This will become here the KQ1. What this will become here? It will become here the students KQ1. Is it? We are telling for the C1. Second one, students, if I talk about here the energy. Now U1 dash. U1 dash what to write here? Half C1 dash V square. The battery is connected only. Okay. So half, it will become here water again kC1 into V square, and half C1 V square is anyhow U1 only. That means here also, students, here if I talk about here this energy, so this U1 dash will be how much here? K U1. And I think so this is the very common when the battery is always connected to the capacitor. Okay, great. Now students, after that, second one, what will happen that here, if we give for what is there? S is open, anyhow S is the open, and now we are going to move for the C2. So students, when you will see here the C2 means you can see this capacitor is not connected to the battery. So what will be the same when the capacitor is not connected to the battery? What is constant? The charge is constant. What is constant, students, here? The charge is constant. So what we can tell here, if we will see here, so students, here, see here, this Q2 dash will be how much is there? Q2. Charge will be same because the battery is disconnected. So Q2 dash will be how much here? The Q2 dash will be Q2. Similarly, students, here, if I calculate here the potential, because the battery is disconnected, so some new potential will come. So what we can tell here you can see as Q2 dash, how much is there, students, here? I can write as C2 dash into new potential V dash, and Q2 how much is there anyhow, students, here? This C2 into V. Correct? Q2 is the C2 into V. So anyhow, if I will write here C2 dash means what we can write here? KC2 into V dash is a C2 into V. So both the sides C2 and C2 cancelled. So here, students, we can write here this new potential V dash is given by, even you can see also, this potential will become here what? V by K. What this will become here, students? V by K. Is it? Potential will decrease because the battery is disconnected. Okay. After that, if we talk about here the energy, so you know very well, charge is constant. That means what we can tell? We can use the formula, see, U is Q square by 2C. So if the charge is constant means U is inversely proportional to C. Okay. So hence, students, if I write here, see, U2 dash by U2 is equal to inversely proportional means what this will become here? We can write as C2 by C2 dash. That means C2 by KC2. So again, C2 cancel. That means new energy will be what here? U2 dash will be how much, students, here? It will become here U2 dash is the U2 by K. Okay. So here you can see Q1 dash equal to KQ1. Here Q2 dash equal to Q2. Here the battery is the connected. Here the battery is the disconnected. After that, here we cancel the B point. Potential V dash equal to V by K. But here in this situation, for this C1, this V is constant. Why V is constant, students? Because the battery is keep on connected. The potential will not change. But for the capacitor C2, what will happen? The potential will change because the battery is disconnected, so V by K. And the energy, how much is there? U2 by K. So depending upon this, if anything you are asking, percentage loss of energy and about the potential charge and all the things you can see very well. Okay, students. So I hope so. All these things you have understood very well. Keep studying, keep growing.